Probably start not. We are developing this website, and you will see a lot of material will be added as we go along. And I wrote here for you guys, please pay attention that the introductions we will do in the end, but these examples are very good examples of the material we're going to cover. And so far, we actually just talked about what is artificial intelligence and what is dealing. Today, we're starting with the first session, in which we'll dive into one of the most important topic in AI. It's called reinforcement learning. This is a beautiful example, and this one, I developed that with JavaScript. And in fact, I used ChatGPT, and I think I mentioned that last time. And that would be a good opportunity for you guys to see how you can use AI to develop AI. Now, this one is very sophisticated topic, basically finding the route from this point to this point and trying to find the shortest way. For example, you can go through this way, and then you get to this point. You can't really, and this is also happened to be the shortest one. You could have gone here this way. You still can get, but it's not the shortest one. How can I teach the computer this game? How can the computer solve it? Now, it seems like we're trying to solve a game, but the truth of the matter is it's a topic that is robotics. You hear a lot about robotics, and the method and the algorithm that you use here, it's applied to many, many other problems in real life. One thing about this one doesn't involve neural network. I mentioned neural network in the first one, I think. Let me see if I can find, in fact, right in here, we mentioned neural networks and multi-layer perceptron or neural networks. We mentioned convolution used in this algorithm. Still, the logic is extremely important in AI. Moreover, as we come later on, as you guys start learning more and more, we will dive into this topic one more time. We'll come to reinforcement learning with deep Q network. This is one of the most sophisticated algorithm, extremely hard. I prepare you to that. This is like playing a game. Maybe I will remove one of those. Let me move it a little bit to the right. In a second, I'll move it to the right and I can describe this game. But the beauty here, this is mimicking real life, okay? This one will come much later. It will take us a little time to get from this one to this one. It's a big jump. It's very similar. This is a game in which, those ones is sliding down, and you have, this is the player. You have to move him so the one that coming down will not hit it. It's like now it went okay. Now, boom, it bumped into it. So the game is over. You lost. This one, it was too narrow. You have to make it wider. Now, this one, it's a little more sophisticated, although it looks like just another game. And the way of solving it, it's very different. And we use what is known as a neural network, a deep neural network. Why is it called deep? I mentioned that also last time. Because when you look, they are using inside convolution inside it, you have a convolution inside it, and you have multi-layer perception. All those ones are part of the solution. Just 1 sec, sorry about it. I have to take this one for 1 sec. Okay, my apologies, I'm back. Okay, so let's go step by step. Okay, now the guy that are really serious about learning AI, I really encourage you to follow up the session today. We're going to spend at least 2 sessions just on this part and learn the code. Spend time learning the code, okay, of this one. This is one of the sophisticated topic. Okay, moreover, I solved it in JavaScript, but I also put for you a beautiful lectures or articles, how you can do the same things with Python, and you'll get similar result. The beauty about the Python, this one I just got to the way it's usually being solved in JavaScript, but you can, and here you can see the evolution of how people were thinking about solving a problem like that. And the last one, 6 and 7, okay, 7 I think mostly, part 7 here in the bottom, it's equivalent to the solution in JavaScript, okay? But I really strongly recommend, guys, you go over the code. I'm gonna go over the code today. My apology, if you are not familiar with JavaScript or you're not familiar with programming, you might lose me. So let me know if that's a little too difficult for you. And I really strongly recommend if somebody needs to extend their knowledge in JavaScript or Python. I don't really teach that. I used to teach that many years ago. But you can take those classes with Academy City of Uganda, okay? They are really inexpensive and they're very good covering JavaScript, Python, databases, and the infrastructure of Django, how to utilize Django. The whole things here is being developed. Even this website, it's developed with Django. Now, as I mentioned previously, you know, Django is open source, it's free. Python is free. JavaScript is free. The database, Postgres, which is extremely good one, it's free. The only thing is, unfortunately, is education. And you can get it here now in Uganda, and I think you should be really happy. Contact Opio and SEO. You have the number here on the top. This is a Ugandan number. They're right there in Kampala. You can join their classes, and I really hope it will help you. I do everything. I didn't really talk much about myself. I try to not to. I do everything for free. Okay, I'm retired already, thank God. And so I have no interest of you guys wasting money or whatever. I really just want to see you successful, even joining these entrepreneurships in Uganda, be part of it, and succeed. It make me very happy to see you successful. Okay? Okay, let's get back to the topic today. First of all, what does it mean? Let's look at try to think about how do I solve something like that, okay? And I will go from this simple one, but you will see the solution is extremely complex. It's even confusing. So if you go even several times over it, don't feel like you are stupid, you are not. Believe me, there are 13 things I went over 10 times or even more until I really understood how it works. So somebody is mute. Yeah. Okay. So if we're going to, let's start thinking about how do I solve it to go from here to here. One way you can say, okay, I can tell this guy walking from here, don't hit the wall and just go straight. If you hit a wall, don't go there. If you get out of the game, don't go there. And if you have it free, you can go. And then, okay, this one is free. This one is free. And now, and this one is the only way you can go, you go down. Now is the issue. I can go right and I can go left. When I'm at this point, how do I know which way I go? I still don't know what will happen 2 steps ahead. So what instructions I can give the guy, that guy got right to this point to go right or left. So one way I can tell him, you know what, try your luck. Go to the right. Okay, he goes to the right, he got stuck. It will go back. Okay, got back, and then it will continue, of course, to the next time. I will stop a second now. This guy that got to this point, if you are his friend and you tell him, I want to do the same things, what is he going to advise you? It will tell you, you know, when you go from here, you go down, don't go to the right, because I went to the right and I was wrong. So the guy that is walking is keeping in his memory, is keeping the fact that this one wasn't very good. So he tells his friend, if you're going this way, don't go to the right. And remember that we'll talk about it as we go along when we're trying to solve this problem. I'm just giving introductions to how to solve it. The solution, as I said, it's much more complex. And when you do it, it's really solving even much more sophisticated problem than this one. Okay, so he's going down, going left, 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 left. Again, he's getting to this point. Should he go straight? Should he go down? Again, he might try to the right. He find out he has nowhere to go. He might go down. So, okay, going down wasn't too bad, but then he has to go back. Okay, so he just made unnecessary move to the right because he won't be the shortest path. So again, but he learned from it that going to the right wasn't the smarter things, and he keep it in his memory. So if he has to go the whole things again, he will not go to the right. Okay, is he going down, 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 down? Here he is also, he's debating with himself. Should I go to the left? Should I go down? Same issue. He might try and keep in his memory. So, and then eventually he's going to go straight. He might go up. And sometimes even if he go up, he might not know. He might think he's in the right way. He will go again up. He still doesn't know if he's in the right way. He goes to the right. He goes to the top. Again, he has a problem going up or down. He might even go up and he make a mistake. That would be really a stupid mistake, but he doesn't know. He might go to the right. It will be shorter, but still it will be worse than just going straight. What is the concept we're learning from that one? So one, a computer doesn't just look at the picture like we do. We have our eyes, we can see the picture, we can see with our eyes where to go. The computer, you only know that there is walls here, it cannot go there. It doesn't know yet, even if he see a place that is empty, he doesn't know if it will be the good one, and he has to learn. That's why it says reinforcement learning. The computer doing a lot of experiment, and he learned the game, and after he learns the game, he finds the right way. So when I click this button, I'm going to do it now. I click this button gives instructions to the computer, learn the game. So he's trying many ways, try, until eventually he finds the shortest way. And we're going to help him how to learn. So learning from the game by trying many times, it's one of the methodology in which he's using. So when I click on it, hey, we see it so fast because it works so fast. But he really did try a lot of, he tried going right, he tried going right here. He find out it's not a good idea, he tried going up. He find out it's not a good idea. And then we're going to develop how he can study very fast and eventually solve it. I just want to give one more thing. So when you play at home, you can play with this game. I clean it up. By the way, if I remove this black, now he have two choices. He go to the left, he will go the regular way, but he can go also to the right. Maybe this one is shorter. Let's try it. I changed the game for him a little bit. I click it, oh, he learned again, and he found this one is slightly shorter, which makes sense. He will go that way. Let's do it again, but this time I'm going to remove this one and this one. So as I removed, he's going to study the whole game again because this is a slightly different game now. He's trying to solve a problem that has extra ways he can go. So now he's going to study the whole things again, and he find the shortest way. Now, this is one. I would like to just to encourage you and so you can appreciate it, I want to give you a homework. You don't have to submit it. Definitely don't submit it, okay? But I'm going to give you a quiz. Not a quiz, it's like a joke. You know, when you're playing a game, and this is a beautiful game for you guys. You won't see it immediately that the logic here is very similar. Solving it have some element in. This is much simpler than the one we're trying to solve, but it's a beautiful game. It's a joke that I heard many years ago. I really liked it, and I always give it to my student. I used to give it to my student. Assume a child went to an orchard of apple trees, okay, and he stole a lot of apples, and it came out of he stole a number of apples. Sorry. This is a good exercise. I won't even talk about it today, but I think it's something would be good for you to try to solve. Number of apples. Okay. Now he left the orchard and a policeman caught him. And the policeman told him, or you give me half of the apple plus one apple, meaning the policeman was asking him, give me half of the apples that you stole plus one apple, and I let you go. So the guy agrees, and he gave it to him. Okay? He's trying to get out. Another policeman caught him. Okay? This is the first policeman. Let's call it the first policeman. Then another policeman caught him. And the second policeman told him the same things. You know what? I know that the other policeman already took half of yours and won, but I'm going to take half of whatever left. So he's going to take half of whatever left, plus one apple. Okay, he gave it to him because he didn't want to go to jail. And then again, a third policeman. Sound like, okay, a third policeman. He told him, you know what, I know somebody have talked, those two policemen already took half of your stuff and an apple. I want the same. Give me whatever left, give me half of it, plus one apple. Okay, the poor things, after he stole the whole things, he passed those three policemen, he's looking at what he has in his hand, he ended up with only one apple. Everybody got the quiz? Okay? The question is, can you solve? How would you solve? How many apples did he stole originally? How many? That's the question. I will just give you a hint. There's many ways to solve it. You can try. You can put 100, and you can do the divide by 2 will be 50, reduce 1, 49, and then you can go back. But you will have to try so many of them. Won't be smart. Okay? You know what? I will give it to you. I'm debating with myself to give you a hint or not. I won't give you a hint. I don't think I might destroy the whole point. See if you can find an easy way, immediate way almost. Okay, if you get the idea. Okay? How I will solve something like that? Okay? You know what I would give? Not really a hint, but you know, one thing you do know, you know the one. And you know this process, what the policemen have done. As a middle problem, try to find out how many apples he had just before he met the third policeman. If you solve that, then you know how to solve the whole problem. That's the hint I would give you. This is a good hint. Okay, it's really help you. But there's an idea here. Okay, try to absorb it. I will talk about it next time. Okay, it's a beautiful quiz. It really is very similar to a logic we're going to utilize here to some extent. This is much more sophisticated. You can, you know, in this problem, if we look, let me refresh it again. You can, you know, this is the end result. I want to get to this point. You know that if you were here, you know already where to go. If you are here, you'll go here. If you are here, you will go here. And then, you know, you're going to the right, okay? The truth of the matter, by the way, the game is such way, like you have closed eyes. Your eyes are closed when you do this game, when you're walking. If you hit a wall, you just go back. You don't go to the wall. Even if you are already here, you don't know if the end result is here. Only when you step into it, you will know this is the end. Okay? So if you are already here and you know already that you hit a wall, and here you hit a wall, you're going to go to the right. That's already your knowledge. Same things for here, you go to the right. Here again, you'll go to the right. When you are here, you don't really know if the end result is here or here. But if you already have done it once, you're not going to go up. So if you're getting to this point, you always will go down. See, you can look at this problem as solving it backward. If I'm already here and I know the end, I can look, if I were here, I know I would go here. So you can go backward. It's like you can go backward and solve it. The only issue here that this kind of a problem, it won't help you because it's very symmetric. Going from here to here, okay? It's the same thing as going from here to here. So going backward won't help you. In this game, this quiz I gave you, going backward might be the right solution. Will be much easier than going from here to here. But this is at least little thinking how you improve your way of thinking. And this is the beauty of all those stuff that we have here. So you can really improve the way of thinking. Let's dive into this way of solving. And I'm going to mention several concepts. First of all, first concept, it's environment. Okay, this game, it's a game in this case, but it could be something else. But I have to learn what the environment. So the environment basically that there's walls, there's places I can walk, and I know where I'm supposed to get there. I know that I want to be in the shortest path, meaning if I will walk wrongly here, I really not getting the right solution. So I have to think about when I think about how to solve it, I will have to take it into account, not just walk around simply. And if I made a mistake one time, next time I'm trying to do the same things, I will remember this will be stupid to go up. So I will have to take it into account. So stage number one, we have to program the environment. So the whole thing's here, we need to kind of computer way to specify this environment. The wall we have to specify somehow. The place I can walk will specify it. The beginning and the end will have to specify it. So that's one thing. Second, agent. What do we mean by agent? The agent is the guy that's going to start from here to here. Just to see that this one is like really studying robotic. When we talk about an agent here, you can think about a robot driving a car. You can think about a robot bringing, people talking about a lot now. It's you get service. By the way, there are a lot of robots in agriculture. Okay, there's robots that working in a car manufacturing. There is robots in many stuff that we are utilizing. So agent is like you can think about as a robot. And the robot, his job is to go from one place to the other place. So we have to specify this robot, and this robot will specify and tell him how to study, how to learn the environment, and he make a decision. When a robot start the beginning, it has to make a decision. If he go up, he will get out of the game. So we will tell him, no, you were wrong. He's going to go back to his place. If he hits a wall, we're going to tell him, the environment going to tell him, no, go back. You cannot go there. So the agent interact with the environment. Okay. When he goes right, he's happy. First of all, you were able to go there. So he will get a confirmation from the environment that it's a good place you can go there. Okay. Now I'm going to introduce another concept. I wrote it here. It's very confusing for somebody never play with that or never know. It looks like confusing, and especially the kind that I'm going to introduce in this game. When a guy went to the right, he was successful in a sense. He went to a valid place. We call it, we give him, the environment will tell him, you went okay, you are in a new place, you were here and now you are in a new place. Moreover, you get a little treat. You know, how do I tell you? You get a little treat. Now, this treat could be like you make some money, okay? Or you lose some money. And we'll talk about it. I will come back to this point. It's very hard in the beginning to understand it. Okay? Okay, the guy got to the second point. If he tried to go down, the environment will tell him, no, you're wrong. Go back. So he's going straight and we'll say, oh, great. You can go there. So the environment telling the agent, this is a valid place. Moreover, here we go, you get a reward, okay? You made some more money, okay? Moreover, and then the same thing is going place by place until he ends up to here. He ends up in here, the game is over, and this guy accumulated a lot of profit as he was going along. Now, if you have a good vision, you will say to yourself, if I give him benefit, I give him a trick every time he walks, he will try to walk as much as possible. He will go even up because he will make more money by going up. Giving him money, it's not a smart thing to give encouragement to the agent. So giving him encouragement, like if he goes to here, he gets, let's say, $5. Oh, he's happy. He will continue. He makes a lot of money. In the end of the game, he won't look for the shortest one. He will try to look for the longest one. So the truth of the matter, if you want to take the code in here and you ask him find the longest one, okay, you give him a positive reward. But how do I encourage him to go in the shortest one? I will tell him, you know what? You're moving from here. You can go there, but you know what? I'm going to penalize you because you already made one step. So I give you minus $5. I think I used $4. I don't remember which penalty I gave him here. But he would get a penalty. And his job is to get to the end with as at least penalty as possible. So if he got to a very small penalty, he's going to end up with a lot of penalties. But his job, the agent, he has to do the calculation. So it will end up with the least penalty. We call it reward. When it's a negative, it's penalty. But it's common in this algorithm to call it a reward. And so don't get confused. The reward will be negative. And the reason is because we want to discourage him to take the longest path, to take the shortest one. So this is the 2-1. Before I continue even, okay, the next concept is extremely hard, okay, and I will spend some time on it. But before I go to that, let me expose you again to the code at least, okay? And I hope this will encourage you to start studying JavaScript. We developed this framework on top of Django, which make the finding the code extremely easy. And by the way, you can see the whole thing is it's online. Let me make it a little bigger so you can see it. Can you see it, guys? Is that clear? Can you see that? You can tell this code, we define here a class called environment, okay? And moreover, the whole environment is not only that, it's all this part is the environment. It's the end of the environment. This is done in JavaScript. By the way, similar things, we have a code in Python, okay? And they get the same result. This is relatively easy, small game. It's only 10 by 10. So JavaScript can handle it very well. Python can handle it very well. But stage number 1, we have a class called environment, okay? In this environment, we have a constructor. I won't go over teaching it. And then we have a function called getNextState. It's another function. Okay, by the way, this is the end of this function. I probably will do it this way so it won't confuse it, because this is part of the object. So the environment has a function called getNextState. State means the place on the game. So if I'm here, what is my next one? The next one is going to be here. Okay, we'll get to that. So it has one function. So we have a class environment, one function called next. The next one is get reward. This one basically telling me if I am going here, what's my reward going to be? If I'm going to here, what is my reward going to be? If I'm going to pay attention, if you go to the end of the game, you get a big positive one, because this is the end of the game. There's no more that I need to encourage you. So this function telling him, by the way, if you get to the end of the game, you're going to get 100. Otherwise, yeah, I was wrong. I put it -10. I think in the Python I put 4. I forgot. But anyway, any other situation, you know, when it's equal to 1, is this is 1, the other empty one is 1. Okay? I think I don't remember the sign. I will look it up in a second. So when you're walking here, you'll get -10 to encourage you. Don't collect too much reward. Okay, you need to find the shortest path. So this one is a function that's telling him, what is my reward? From one place to another, you will get a -10. Okay, and no, okay. And then when sometimes, and I will get into that, I will talk about it later on. Sometimes if he gets lost too much, I will stop him and tell him, go over. So start all over again. And then I won't penalize him. It's not important. I will just give him -1. But basically is, if you walk, you get -1 on -10 on every step. If you get to the very end, I will give you a reward of 100. Then you also, the agent, you will know you got to the end of the game because you see the high one. Now, this one is just a helping one, just telling him when did he get to the end of the game. But that's less crucial function. Is its terminal mean, did I get to the end of the game? And we will see how that interact as we go along. For now, what I would like you to understand that when we deal with reinforcement learning, also when we talk even the deep learning, we will always have an environment, and we have to define it, and then we'll have an agent, exactly as I described here, an agent. What the agent need, the agents will have several functions, okay? And I will go over that at least twice, okay? So if you don't get it the first time, don't hit yourself, okay? You are very normal, okay? You need really to go over that several times. And I would advise you, listen to this recording of today, listen to it at least twice, at least, okay? And if you can handle it twice, good, you are very good. And here you have beautiful code. You can really actually learn from the code itself. We have another class, okay, called agent. And the agent, by the way, as you see in the environment, we have a constructor. By the way, a constructor, it's like a function that when you create the environment is the first function that the environment is calling to. And then what it does, it takes the maze, it's the structure of the environment. I will define it in a minute. You will see how I'm defining this environment, okay? So when the environment is being created, it takes the maze, the structure, is going to keep it inside, and is going to get what is the place of the start of the game, which is this one, and what is the goal, the end of the game, which is this point. Okay, so I'm telling him the environment, I'm defining the environment, I'm defining the whole structure, and I'm defining the beginning and the end. The agent has also constructor. Okay, that's slightly complex. I won't get into that, not today. I will get into that next time. we have all these parameters, alpha, and we have gamma, and all of those, I won't get into them right now. We'll come to that, okay? Gamma, gamma, alpha, epsilon, all of those are very important. Decay, epsilon for decay of the epsilon, mean episode. We'll get to that in the future. For now, pay attention when the agent is being created. I am telling him the environment. So this one is basically the definition of the environment. So the agent has to know he's playing the game. He's trying to win the game. I have to describe to him what the structure of the game. So no surprise that when the agent being created, the first things I'm giving him is the environment. So the truth of the matter, those stuff, we are helping the agent to utilize them because we're going to help the agent how he is going to solve. We're really acting as the agent. We are trying to learn, and we're going to use the algorithm of this AI to solve the problem. And the AI algorithm has those parameters: the alpha, the gamma, the epsilon, the decay, the mean position. We'll talk about them in the future. Now, I'm going to talk about one more concept, which is extremely important. It's called Q-table, okay? It's quite known. It's almost everywhere you will see the people define it as a Q-table. What does it mean? Why do I need it? Okay, and let me explain that one. It's a little hard, so if you don't understand it, it doesn't mean you are not smart. It just means it's a little hard and you will catch it in the end. We're going to develop algorithm. I haven't told you the algorithm yet, okay? That will come later on. In 4, we'll give it a try, okay? And I will go over it again next time, okay? I will go over it again, I promise, at least one more time, at least. But before that, one of the foundation of artificial intelligence or reinforcement learning is to build up a table that tells me how important is every point. I will explain. When I'm standing in this point, like I will click it here so you can see which point I'm talking about. When I'm standing here, if somebody told me that this one is more important than this one, if this one is more important than this one, I wouldn't go to this one. I would go only to this one. When I'm standing here, I want to make a decision, should I go here or here? If I know that this is much more important to get me to the final place that I would like to go to, would be beautiful. So what the Q-table means is we're going to estimate, we're going to do some calculation, and we're going to give a number to every square along the whole game. So every square will have a number. If we are successful to do that, we already kind of solved the problem. Why we solve the problem? The agent that's starting from here, it will start going according to the value. It gets to this point. If this one has a higher value than this one, it's definitely going to go to here. And if I'm leading him, he always will go to the places with when every time he got to a position, he has to make a decision going here. Going here or going here, he always will take a place that has a higher value. That's why that's called Q-table value. You can even call it. And by creating that Q-table, by the way, I'm almost saying it's the right way. I will specify it in a minute, okay? If I know that the value of going down is more important than going to the right, I will never go to the right. So when we're solving this problem, one of the things as a step in the middle, before telling the agent how to behave, we're going to calculate the value of every square here. And then after I know the value of every point in the middle, the agent has nothing, doesn't really have to think too much. He will just go from one place to the higher place all the time. And that will be the decision. Okay, that's called a Q table. Okay. The next one called value function, and this is slightly harder. And let me distinguish between the two. Okay, let me distinguish the two. And by the way, I intentionally call it value function, but the truth of the matter, I didn't define it for you. I didn't want you to get confused. Okay, if you studied it in mechanical engineering, you will see that there is something called Bellman equation, and I won't get into it. Okay, the beautiful thing is really sticking to that one, at least the first time. You will see it will do much better than otherwise. When I talk about value function, the truth of the matter, I'm talking about the value of the Q table. And when we talk about the Q table, we're trying to find out the value of every cell. And the right way to say it, which in this case won't make much difference, in future cases as we go, I'm standing, let's say, in this point. What's the value of this point? How good is this point? I'm not saying how good it is. When I'm standing here, how good is to go to the right when I'm standing up here, or if I'm going to the left? In this case, it's the same thing as the value of this one or this one. It's a little subtle distinguish, but it's a very important distinguish. When I'm standing here, I'm trying to see how important is going to the right versus going to the left. And that's what this Q table does. For a specific place, how important is going to the right versus going to the left. That's really what this table is all about. So I'm not really trying to measure it standalone by itself. I'm doing it relative to the actions I can make. This is an easy game, but there will be a lot of games that are much more sophisticated. This game is much more complicated. And this one will solve it totally in a different way. But this concept repeating themselves, you will see, this concept repeating themselves. So if you didn't understand it, don't hit yourself, okay? We'll come to that. But from code point of view, let's look at where this Q table is programmed. The Q table is defined right inside the agent in the constructor. It's right here. If you notice, it's an empty dictionary. If you know a little bit JavaScript or Python, you know that this is the way we define dictionary. What's going to be inside it? We're going, as we will see when we're training it, we will specify every cell here and every action, and we put the value there. And the one that in the beginning, when the agent started the game, he doesn't really know anything. That's another thing that you need to, another concept. I would really go over a lot of concepts today. I will go over them a lot next time. So don't be discouraged. As I promised, I will go over it several times. I need to tell the agent the structure, but in the beginning, nobody knows how important is going to the right of this point or going to the left of this point. So in this function, initialize Q table, it's a function, which we're going to see it in a second. It's just putting a random numbers, just numbers. And as we train the agent, and when we teach the agent, and as the computer learning the game, it will fix and it will eventually will find out the value or how important each one of those places. So this function, initial Q table, it's really defined inside the agent. Okay, everybody got it? Okay, so now let's go over that one. And let's see, you can see we have two loops, a first loop and a second loop. And then inside the loop, we're defining the dictionary of this dictionary. Okay, this is going to be a dictionary. If you know in the dictionary, you specify the key and then you put the value of it. And here the value, it's a little more sophisticated. It's a little, you have 4 actions that you can do. In any place, let's say, again, we're going to this point. If I'm here, I can do 4 things. I can go up, which will be stupid. I'm going backward, so it's a stupid move. I can go down, down. I will hit a wall, so it doesn't make sense, but I can try to do that. So there's 4 possibilities: going up, going down, or going to the right, or going to the left. So from every place that I am in the table, I can go to one of those 4. And please pay attention. When we initialize this Q table, in fact, we're just putting 0 everywhere. We're not really doing anything. It's just feeling like you have a long dictionary, and that dictionary going to be empty. You know what? Just for the fun of it, so you can get a sense, this dictionary is totally empty. You see that? It's totally empty. Okay? If you look at that here, you will ask yourself, how does it look like? And I strongly, strongly recommend do it yourself. Work with Opio. You don't have the code for this one, okay? But work with Opio, okay? Join his classes. You will go over those stuff with him. Let me give you something. I will show you how it looks like. And this is the right way to study. Bear with me a second. I will take a little bit code from here so you can really view it. So I will do it so you can see how it looks like after initialization, okay? If you don't really know programming yet, I hope I at least convinced you to try to learn how to program. So we're going to take this dictionary and we want to see it after it's being initialized. So I'm going to put it right here. By the way, you see, it's really online, the whole thing. So we're going now to, I always like to do this one. Start a new one. Here we go. See how it's just showing you how it looks like. And if you have a good eye, is really putting, this is the key. 0, 0, it means really the beginning, or you started. Even for that one, is giving you the Q table look like. If you go up, everything is 0. You notice? Everything in the Q table is 0. There's nothing. And it's going to be changing. You will see as we get to the end. Okay? I hope that this is a good way to study, when you're studying something. So I'm going to remove it. We don't need to see it again. But I tell you what I would like to do. I might do it to the end of the game.